Welcome to the Project Management Prepcast, the key to PMP exam success. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to the Project Management Prepcast, where we send you on a controlled trajectory towards your PMP exam. I'm your instructor, Cornelius Fichtner. One of the biggest issues on every project is your project scope and controlling scope creep. Scope creep can lead to project failure, or at a minimum be very costly and delay your project schedule. To avoid scope creep, you need to readily identify variances from your scope baseline and control all the required changes to your scope. This is exactly what the control scope process will allow you to do. So, in this lesson, we discuss scope creep and ways to avoid it, sources and types of changes and the perform integrated change control process. We talk about avoidable scope changes. We look at variance analysis, good and bad variances, and we look at work performance data and work performance information. The official PMBOK guide definition is that project scope management includes the processes required to ensure that the project includes all the work required and only the work required to complete your project successfully. And to help us with this, we have our 6 processes of project scope management. It all begins with the planning process. Plan scope management. This is the process of creating a scope management plan that documents how the project scope will be defined, validated, and controlled. Our second process is collect requirements, the process of determining, documenting, and managing stakeholder needs and requirements to meet project objectives. And then the third process, the process of developing a detailed description of the project and product, is called define scope. Once we have our scope defined, we really only have a big blob of our scope. We know what we need to do, but we can't really do it all at once. So we have to break this down into smaller and more manageable bits. This is where the process of Create WBS comes into play. The process of subdividing project deliverables and project work into smaller, more manageable components. After this, we can hand our scope over to the executing process group, Project Integration Management to be precise, where it will be developed. Once it is developed, the customer still has to tell us whether or not it's okay or not. That's what we have the process of validate scope for. The process of formalizing acceptance of the completed project deliverables. At the end of this process, we have accepted deliverables, accepted by our customer or sponsor. And to keep control of all of this and making sure that we do not have any scope creep, we have the process of control scope. This is the process of monitoring the status of the project and product scope and managing changes to the scope baseline. And when we come to this slide here about into which process group our individual processes fall, you should start to see a tendency. The tendency is that the first process is always a planning process, and the last process is always a controlling process, which means control scope falls into the monitoring and controlling process group. The main concept to understand in control scope is that this is where you avoid scope creep. Scope creep refers to uncontrolled changes in a project or product's scope, which can occur when the scope of a project or product is not properly defined, properly documented, and properly controlled. It is important to realize that changes occur on all projects. It's just unavoidable. Typically, these changes take one of 3 forms: requested changes from the project team, sponsor, or customer, changes required to correct something such as a defect, and changes to prevent the occurrence of an unwanted or undesirable effect in the future. Scope creep can be avoided by requiring that all changes go through the Perform Integrated Change Control process. That ensures that all changes are made to the appropriate project documents, are accepted, approved, and then only implemented. The control scope process is used to manage and oversee those changes that are approved on the project. Let me give you 5 ideas of where and why scope creep can happen. First of all, it's usually a result of the fact that the project team poorly defines its initial requirements. Remember, it's as important to say what's in your scope as well as what's out of your scope as well. There could be failure to involve stakeholders and users in the early stages. If this happens, enhancement requests or new functionality is often just squeezed in after the scope baseline has been set. And talking about the scope baseline, you could simply have an inaccurate or missing scope baseline, and nobody really knows what the baseline is all about. Then things just happen and are being changed. Or there could be poor change control execution, which has a lot to do with weak management or lack of sponsor to simply push back many change requests, or not even require that change requests have to go through the integrated change control process. Changes come to our project from various sources and take various forms. So let's take a look at the sources of changes and then also the type of changes that we can get. So first of all, sources of changes. There could be external requests, such as from an external customer. There could be internal requests, such as those requests that come from your project team, your project sponsor, or an internal customer, and so on. There could be errors or omissions in the scope of the project or the product, and that will often cause a change. Or then there are these so-called value-added changes that might not be necessary or beneficial to the project, and after a careful cost-benefit or strategic analysis, the time or costs of implementing these value-added changes may actually outweigh their benefits. And then in regards to the type of changes, there could be a change in requirements. For longer projects, especially IT projects, additional requirements are requested by the client. This is one of the major types of changes that often creates headaches for the project managers and the project team. There could be design changes that are required when a new feature or new functionality is added. There could be technological changes. This can be beneficial or detrimental to the project. For example, a change in software programs from one language to another because of an increase in flexibility or adherence to a new standard. There could be cost and schedule changes. These can occur over time due to a rise in commodity costs or a shortage of qualified staff. Regulatory changes that are often mandated by governmental bodies. If your project is global and the regulatory changes burden you, that can be quite high, so you may have regulatory changes happening to you. Or there could be strategic business changes as well. These are usually requested by upper management teams as the business strategies change that create necessary change requests to your project cost, to the schedule, the resources, deliverables, or your project scope. Some changes to your scope are very avoidable and not unforeseen or driven by normal changes in the project environment. Here are a few examples of the sources of these changes in your project's scope. First of all, there is a lack of clear understanding of the requirements or an incomplete set of requirements. Then, lack of detailed definition of both the in-scope and out-of-scope work. When defining scope, be careful of requirements that may be assumed to come with others. Document both what's in and what's out. Then there is gold plating or continuing to enhance the deliverables until they are absolutely perfect. Don't forget the 80-20 rule of diminishing returns. And then there is a lack of fundamental understanding of the impact of proposed changes to the project. Oh, it's just a small change, but the rippling, the domino, the snowball effect is not understood because there may be a downstream effect that you simply haven't considered in your analysis. And finally, simply the inability of the project manager or sponsor to push back and just say no. Remember, project management is not a popularity contest. It's the most difficult yet most important word to use. As usual, let's first take a look at our ITTO overview for the control scope process. We have a total of 5 inputs, a single tool and technique, and then again 5 outputs. And just as we saw in the previous lesson, validate scope, a major focus here in control scope is change control. So this is part or related to, it's a cousin of the integrated change control process. And here are the 5 inputs to the control scope process: the project management plan, requirements documentation, work performance data, requirements traceability matrix, and of course organizational process assets. Note that most of these have to do with requirements. Not surprising, we're trying to control our scope, we're trying to control our requirements and make sure that it doesn't just grow wherever it grows, but that it is controlled. So our first input is the project management plan. But remember, the project management plan, this is not just a single document. It consists of many subsidiary plans and other types of documents. And the ones that we are really interested in here in controlling scope is the scope baseline, the scope management plan, the change management plan, the configuration management plan, and the requirements management plan. We use the scope baseline to compare it to actual results to determine variances and see if there are corrective or preventive actions that we need to take. We use the scope management plan because it documents how the scope should be monitored and controlled on the project. And remember, this is the process of control scope. It's an important input because it tells us how to control our scope. We use the requirements management plan because it defines how the requirements should be analyzed, documented, and managed. The next 2 subsidiary plans within the project management plan are the change and the configuration management plan. The change management plan defines the process for managing changes across all elements and all phases of the project. And the configuration management plan defines those items that are configurable, or the items requiring formal changes, as well as the process for controlling changes to those items. So you can see all 5 of these subsidiary documents are important inputs to the process of controlling your changes. The requirements documentation was originally an output of the collect requirements process and then becomes an input to all the subsequent processes, including here controlling your scope. Requirements documentation should be unambiguous, measurable and testable, traceable, complete and consistent, and also acceptable to key stakeholders. And one of the things that we're going to do in this process here, we're going to ensure that this is in fact the case. So we're going to make sure that the documentation in this document, in this requirements documentation, comes up to these 5 quality standards here. And of course, finally, well-documented requirements, they make it much easier for us to detect variances or deviations, which must be controlled if our scope baseline is to be maintained. The requirements traceability matrix, just like the requirements documentation, was an output originally of the control requirements process and is now an input here to control scope. First, it can be used to determine the impact of any changes, since we can follow a change in requirements all the way through testing to the final product in this traceability matrix. Then the traceability matrix is a grid that visually links requirements to deliverables, and as such it provides a structure for managing changes to the product scope. And that's what we're doing here. We're managing, controlling changes, and this structure will help us with that. Some of the organizational process assets that help us in controlling our scope are existing formal and informal scope documents from similar projects that were done in the past, control-related policies and procedures that will likely govern the methods that are used to control and manage our scope here. Then we have standard monitoring and reporting methods used by our company or our organization, and a very common organizational process asset, project templates that can be used to assist us in our goal of controlling the scope. And then our final input, work performance data, which we also discussed as an input in the direct and manage project work process. Again, our focus here is on how this data is used to control the scope of the project or product that we are working on. Work performance data, these are raw observations and measurements that were specifically chosen to track project progress and adherence to estimated indicators of performance. This data is collected to be analyzed and passed on to controlling processes such as control scope. And examples here include work completed, start and finish date, number of change requests, cost, deliverables that have been completed, number of defects, and so on. You should now see a pattern emerging as each of our inputs provides a means to identify deviations or variances from expected results. For example, here, work performance data, the number of deliverables completed should somehow match with the number of deliverables that we had originally planned. If more deliverables have been completed, that could mean that somehow additional deliverables have been added in to our scope without being controlled. And this little example of comparing the number of deliverables planned and completed takes us straight to our tools and techniques, because this example was in fact an application of our one and only tool and technique called variance analysis. The PMBOK guide defines variance analysis as a technique for determining the cause and degree of difference between the baseline and the actual performance. These performance measurements are used to assess the magnitude of variations from the original scope baseline. So, variance analysis. How do we do it and why do we do it? Well, simple. First, we compare the work performance data that we have gathered to the scope baseline to determine if there is a variance. And then second, if a variance exists, we try and answer a couple of questions. First of all, what is the root cause of the variance? This is because it will determine our response, depending on whether the variance is due to a defect, incomplete or ambiguous requirements, changes that were made outside of the change control process, and so on. And then second, we have to ask ourselves, what is our action? What do we do for each of these variances? This, in essence, is variance analysis. And it allows us to, well, if we keep a tight control on all our change requests, but in the end nobody checks if we're actually producing what we said what we would, well, we'd have a problem. And by applying the variance analysis, we make sure that we do in fact do as we had planned. But let me give you an example for a situation where you find a variance, but you decide to update the baseline instead of fixing the problem. So let's use an example of a project that produces as deliverables plastic casings. When the comparison is done, it is determined that the plastic is much more flexible than what was originally called for in the technical specifications. But it is then determined, wow, that is a beneficial variance. So given this additional flexibility is a desired quality, we decide to keep that variance. So the next step would be to begin documentation by issuing a change request to update this characteristic of the plastic casing in the scope baseline. Yes, it is still a change request, but it's a change request to update the scope baseline and not to fix the variance found. Although most variances, they will lead to corrective or preventive action and impact scope occasionally, the variance is beneficial here, and all that is needed is an update to the scope baseline. This is maybe an unusual example, but if you have a variance that you like, why not keep it? So we took our inputs and we applied our tool and technique of variance analysis to them, which now leads to 5 possible outputs. There is work performance information, change requests, project management plan updates, project documents updates, and organizational process assets updates. Let's look at the details here. Work performance information is produced throughout the project lifecycle, and it includes correlated and contextualized information about how our project scope is performing versus our original scope baseline. It can include a categorization of changes received and approved, and at a minimum, this information will include the scope variances that have been identified and the cause of these scope variances and what the impact of the scope variance will be to schedule and cost. Remember, these are all dependent constraints, and perhaps there will even be a forecast based on the data gathered of the future scope performance. This work performance information provides the foundation for informed decisions about scope later on. Remember that one of the questions that we asked during the variance analysis was, are we going to have to do something about these variances? And if so, what? If the answer to the question is, yeah, we're going to have to do something about it, one thing we may need to do is to create a change request. But what is a change request in terms of scope? Well, a change request could be a request to modify the scope baseline or one of the subsidiary plans that were our inputs. Remember my example there with the flexible plastic casings? Well, this may need to go into some form of technical documentation as well. It can be a request for a preventive or corrective action to take place to prevent the deviation or variance from continuing to occur. It could be a request to repair a defect in the process or products produced, or both. A very common one is for an enhancement request, perhaps for a new feature in a software product. But all change requests follow the same standard process as outlined in the Perform Integrated Change Control process. Another output of the control scope process are updates to the project management plan, or rather its components. Typically, we're talking about baselines here. A specific and obvious update would be to modify the scope baseline. Examples where this would happen are approved changes that will impact the project scope, and when we make updates to the individual components of a baseline, such as the scope statement, the WBS, and the WBS dictionary. Sometimes the appropriate action, on the other hand, is to update other baselines as they are affected by changes in scope, and two that immediately come to mind are the schedule baseline and the cost baseline. Once the updates have been made, the revised documents are reissued so that these changes are then communicated to the entire project team. Two other project documents that may be updated as an output from our process here were Initially, two inputs to this process. They are the requirements documentation and the requirements traceability matrix. Remember, we're looking at requirements, we're reviewing them, we're making sure everything is still correct. Well, if we find any deviation when we apply our tool and technique of variance analysis, we're going to have to update our requirements documentation. We're going to possibly have to update our requirements traceability matrix. In regards to our final output, the updates to the organizational process assets, we're mainly talking about things like causes of variances as well as corrective actions and the reasons why specific corrective actions have chosen. Of course, these two items in themselves, they're not organizational process assets, just information that needs to go into your organizational process asset. And what type of asset, you ask, might this be? Well, we're talking about lessons learned documentation here. The variances, the causes, and the actions taken, they all become part of the lessons learned documents, and they may and should be used by future projects and by our own project as a reference. Let's review what we do in the process of control scope. First, we need to execute a variance analysis, and we use the project management, configuration management, and change management plans, as well as our scope baseline, in order to perform this variance analysis. Then we determine if a variance exists and what the proper course of action should be to correct it. Next, we submit change requests and use the perform integrated change control process to approve and implement these changes. And finally, we make the appropriate changes and revisions to baselines and additional project documents and reissue the newly modified documentation. Let us end this lesson with a PMP exam sample question, which reads, which of the following regarding control scope is incorrect? Is it A, changes in scope are called scope creep? B, change is inevitable? C, changes should be processed through the perform integrated change control process? Or is it D, some variances are beneficial? Again, I'll give you a few seconds here for this. The answer is, of course, A. Changes in scope are not called scope creep. Only changes in scope that are not approved through change requests and the perform integrated change control process are considered scope creep. And of course, this is a main focus of this process. We hope to identify scope creep and eradicate it from the face of the earth. And this concludes our look at the control scope process. So it's time for Justine to say,
it's time to motor.
And I say, until next time.